Hello everybody. Now in this video we will consider the mechanical system. As you know there are the two type of motion. The motion which takes place along a straight line, then it is called the translational motion. And there are the three type of the motion. There are the three types of the forces that resist the motion. The first one is inertia force. Suppose a body having the mass m and the displacement is x, then force will be equal to the md2x upon dt square. The second is damping force. Here we consider a piston and a cylinder, and the force is given by b dx over dt, where b is the damping coefficient. The third one is the spring force. A spring force is spring stores the potential energy, and the force is given by Ft is equal to k into xt, where k is the stiffness constant. Now consider the second type of motion. The second type of motion is the rotational motion. That is when the body is moving about a fixed point. Then it is called the rotational system. So there are three type of torque exist. The first one is inertia torque. This is the inertia torque, which is the property of an element that stores the kinetic energy of the rotational motion, and that is given by j d2 theta upon dt square. The second one is damping torque. The damping torque is the product of damping coefficient and the angular velocity omega. So here you can see that v omega t, where omega is the angular velocity. The third one is spring constant. Third one is spring torque. The spring torque is the product of torsional stiffness and the angular displacement. So T is equal to K into theta T, where theta is the angular displacement. Now, what is the D'Alembert principle? D'Alembert principle states that for any body, the algebraic sum of the externally applied forces and the forces resisting motion in any given direction is zero. Now, take the example for the D'Alembert principle. Consider a very simple mechanical system in which the spring dashpot uh, and the mass m. The mass m is hanging and the force Ft is applied. Here we consider the three type of resisting forces. The resisting force, inertia force, which is given by md2xt upon dt square, damping force, and the spring force. Now, according to D'Alembert principle, the algebraic sum of all the forces is equal to zero. So here equal to all, we add all the forces equal to zero. Consider the rotational system, external torque, inertia torque, damping torque, and spring torque. So according to D'Alembert principle, the sum of all the torque will be equal to zero. So for any body, the algebraic sum of externally applied torque and the torque resisting rotation about any axis is zero. This table compares the translational and rotational motion, where the force F is the analogous of the torque T. Acceleration is the analogous of angular acceleration. Velocity is analogous to the angular velocity. Mass m is analogous to inertia, moment of inertia j. Take an example of the mechanical system. Here we draw the first body diagram. You can see here the two masses are hanging with the help of the two spring and the dashboard. This is the free body diagram. Here you can see the force Ft is acting downward on the mass m1. So according to Newton's law, an opposite force will exist. So this is m1 d2 x1 upon dt square, which is the force acting opposite to the downward force, and two other forces are due to the dashpot and the spring constant k. In second diagram, you can see this the two forces because of the spring K1 and dashpot B1 according to Newton's law, an opposite force will exist this m2 d2 x2 upon dt square, and other two forces are due to the second spring and second dashpot. Now here apply the D'Alembert principle and we find the algebraic sum of all the forces equal to 0. This is another example of the horizontal. Here the two, again here the two masses M1 M2 which are connected with the help of the two spring K1 and K2. X1 X2 are the displacement. Again we draw the free body diagram. Here the force Ft is existing on the mass M1. So the two forces are as shown in the figure. According to Newton's law, then a force m1 d2 x1 upon dt square will act opposite to the force Ft. So these are the free body diagram, and here we write the differential equation according to D'Alembert principle. The sum of all the forces equal to 0, and then we take the Laplace transform and solve the equations about x2 upon fs or any other. Thank you so much.